We are here to help.
In the previous video, we explained how to calculate the area under the normal distribution curve given a certain z-score. In this video, we'll explain the situation in reverse. In other words, given a certain probability or area under the curve, how do we determine the corresponding z-score or value? Let's consider the following example. On your last statistics test, your class scored a mean of 67, with a standard deviation of 8.3. The scores follow a normal distribution. What was the 75th percentile on the test? In other words, what score on the test has 75% of the data at or below it? Using probability notation, this is saying that the probability of x being less than or equal to some unknown value k is equal to 0.75. We also know that the mean is 67, and the standard deviation is 8.3. We begin by drawing a picture of the normal distribution curve, labeling the mean score in the middle. Since the mean and median are equal in a normal distribution, the mean splits the area in two equal halves. 50% is below the mean and 50% is above the mean. We are being asked about the score that has 75% of the data to the left of it. This means that our unknown score k must be larger than the mean. In order to calculate k, we first need to determine the z-score that has an area of 0.75 to the left. This is illustrated by the same diagram with a different scale. Then we can use the z-value formula along with the mean and standard deviation to solve for the x value, k. First, let's find the z-score. There are two different z-tables that can be used depending on your course. A cumulative table that shows both positive and negative z-values, or a one-sided z-table that only shows positive z-values. We will first look at the cumulative table. This table is very convenient for this question because the cumulative areas are exactly the areas to the left of the z-scores. We will look in the center of the table for the area values closest to 0.75. 0.7486 is slightly below 0.75, and 0.7517 is slightly above 0.75. The closer of these two values is a 0.7486. We will select this one. That corresponds to a z-score of 0.67. Here is how to look up the same score using the one-sided positive z-table. If this is what is used in your course, this is the space-saving table. Because the normal distribution is symmetrical about the mean, you can use the same table for both positive and negative z-scores. It is important to remember that if you are using the one-sided z-table, that the areas listed in the table are between 0 and the z-score. In our example, we know the entire area to the left of z is 0.75. We cannot directly look up this area in the one-sided table. First, we need to find the area between the mean and the z-score. This area will be 0.75 minus 0.5, since 0.5 is the area below the mean. That means the area to find in the table is 0.25. The closest area to 0.25 is 0.2486. Which corresponds to a z-score of 0.67. Now that we know z, mu, and sigma, we can substitute in these values and solve for k. Using algebra, we can rearrange this equation to isolate for k. This means that the score of 72.56 was the 75th percentile on the test. We can also write that the probability of x being less than or equal to 72.56 is equal to 0.75. Another common scenario is determining the score given the area to the right of it. Consider the following example. Find the z-score that has an area of 0.9686 to the right of it. In other words, find the value of k so that the probability that z is greater than or equal to k is equal to 0.9686. We begin by drawing the diagram. Since the given area is to the right of the score and it is more than 0.5, that means the unknown z-score must be a negative value. We draw it on the left side. and shade in the given area. Before we can use a z-table to find the z-score, we need to manipulate the given area so that it matches what the z-table displays. The cumulative table works with areas to the left. Here, that means the area we need to look up is 1 minus 0.9686. We look in the center of the cumulative table and see 0.0314 corresponds to a z-score of negative 1.86. The one-sided table works with areas between 0 and the z-score. Here, that means the area we will look up will be 0.9686 minus 0.5 because we want to exclude everything that is not between the z-score and 0. Remember that the normal distribution is symmetrical about the mean, so the area between a z-score and 0 is the same whether the score is negative or positive. We look in the center of the one-sided z-table and see 0.4686 corresponds to a z-score of 1.86. However, we know from our diagram that the z-score must be negative, so we include that in our answer. So both tables produce the same answer. Negative 1.86 is the z-score that has an area of 0.9686 to the right of it. You may encounter other scenarios where the indicated area is not to the left. Drawing the diagram of the normal distribution and shading appropriately can help you determine when to add or subtract areas.